Making use of self-similarity within textures allows us to perform rapid, global operations interactively. Here we see the simplest case of painting a solid color repeatedly across an artificial texture. The opacity of the paint at each pixel is made inversely proportional to the neighborhood distance of that pixel from the target pixel selected by the user. In this next example, we first paint a solid green color over regions of a bark texture. We follow this by the application of a cloned moss image over the same portions of the original texture. It is of course possible to clone more structured images onto a texture using the self-similarity tool. Here we see an effective example of cloning a familiar sign onto a brick wall. And here we see another example of the cloning tool used to paint an aging advertisement onto a roughly planar surface. Self-similarity can be used to affect the shape of the texture elements as well. Instead of using neighborhood similarity to control opacity, we now use it as a measure to control local area expansion and contraction. Areas which are similar to the selected pixel expand. Those dissimilar contract. As in this case, it is often not necessary to move the mouse large distances within the image. This is a direct result of the fact that the tool is exploiting the inherent self-similarity of the texture. Depending on the texture and on the degree of area expansion, high-frequency details can sometimes be lost. In this case, the flower heads become conspicuously stretched. To overcome this, we employ the super-resolution method of Hertzman et al. To reintroduce the lost detail while maintaining the expanded shape. Finally, for the sake of comedy value, we apply the self-similarity warping to a human face.